Hello everyone, welcome to our very next session of fluid mechanics and hydraulic machines subject. In this session, we'll cover about the hydrostatic forces which is applied on a different surfaces. Okay, so let's start our this chapter. In this topic, we'll see the different hydrostatic forces. That means your static forces, which is applied on a horizontal surfaces, vertical surfaces, as well as in inclined surfaces. Okay. So as we know that there is a forces which is directly perpendicular to the any kind of surfaces. It may be a horizontal, vertical, or an inclined. So what is the effect of that force or the pressure force on that surfaces? And we need to find out at the same place the total forces and the total pressure at that point. So let's start our this session. But first of all, let us see that what is the total pressure, as in every session of examination there is one question which is asked somewhat like this: define the total pressure and the center of pressure. So first of all we need to identify that what is total pressure. So total pressure, that is defined as the force. This is the one kind of force which is exerted by the static fluid. Yes, we need to take care of this static fluid. So the total pressure, which is defined as the force that is exerted by this static fluid on the surface either plane or the curved surface. When the fluid comes in a contact with surface, this force is always acts normal to the surface. So in a simple language, you can see that over here it is a one horizontal surface, and on that surface there is one static fluid. It means it is bounded with boundaries, and it is collected in any measuring tank. Okay, so as this fluid is a static fluid, and the force which is exerted by this static fluid on this surface, and this force is known as the total pressure force or the total pressure. And this force which is always act normal to the surface, that means you can see that like this, which is the normal to the surface. So this type of force is known as the total pressure. Okay, so that was all about our first definition, which is total pressure. And the next is center of pressure. What is center of pressure? So the center of pressure is defined as the point of application. Center of pressure, which is the point of application of total pressure on a surface. So let's say in this case there is a pressure force or a total pressure is acting as normal like this on this point, at a point G, at a point G. Okay, so what is the center of pressure? The center of pressure, which is point of application of total pressure, it means your total pressure which is applied on this surface at this point G, and that is known as the center of pressure. There are mainly four cases of submerged surfaces which the total force and the center of force is to be determined. And these surfaces are known as: first one, that is vertical plane surface; second surface, that is horizontal plane surface, as you can see that in this figure, which is the example of horizontal plane surface; third one, that is inclined surface; and fourth one, which is curved surface. So throughout this chapter we will cover all these four surfaces with their examples. So if we talk about our examinations, then there is a one question out of these four, somewhat like this: explain the inclined plane surface in terms of total pressure and center of pressure, or explain the inclined plane surfaces in terms of hydrostatic surfaces. So I hope you understand about this total pressure. Again, I am simply summarize that total pressure, that is the one kind of force, total pressure, which is one kind of force that is applied by static fluid on any surfaces. So this one is your total pressure. And the center of pressure, that is the point of application, at which point this total pressure is applied on the surfaces. So this point is known as your center of pressure. So these two are most IMP definition: total pressure and center of pressure. Okay, let's move on the very first and basic surface, and that is our horizontal plane surface. Okay, first, that is horizontal plane surface which is submerged in a liquid. So in this case, in this diagram, you can see that there is one horizontal surface which is parallel to the free surface of liquid. So it is your horizontal plane surface, and that is fully submerged in a static fluid. Okay, so consider a plane surface immersed in a static fluid. At every point of surface, it is the same depth. Yes, it is not inclined. So the every point of this surface, which is at the same depth from this free surface of liquid, the pressure intensity will be equal to the entire surface. The pressure which is applied on this surface by this static fluid, that will be equally distributed on the surface, and the value of pressure, which is P, that equals to rho GH, where we can say that the H, which is the depth of surface, H, that is your height from the free surface, which is the height of your surface from the free surface of liquid, that is denoted by H. A, that is the total area of surface, and then your total force, that may be the force that equals to pressure into area. Okay, as we all know that the formula for the pressure, that is P equals to force upon area. So from this you can write that your force, that equals to pressure into area. Okay, so simply this F, that equals to pressure into area. So in this equation, let's put the value of pressure, and that will be your rho GH. So here it is the rho GH, and the area of this surface, that is A. So this one is F, that equals to rho GAH bar. Yes, again the new term, which is H bar. And what is that H bar? For this horizontal plane surface which is fully immersed in liquid, the H bar, that is the depth of CG, which is the center of gravity, depth of CG at this point. You can see that this one is G point. Okay, H bar, that is the depth of CG from the free surface of liquid. So here it is your H bar, which is again your simple H. H equals to H bar for the rectangular or a square plane surface which is fully submerged in a liquid at the same depth of every point of surface. And your H star, that is again a new notation, that is the depth of center of pressure. Depth of center of pressure, that means the pressure which is applied on this surface. Okay, so that is the depth of center of pressure from the free surface, and that is your H star. So we need to take care of these 2 points or the two notations. First one is H bar. H bar, that is the depth of CG from the free surface, and H star, that is the depth of center of pressure. CG, let's see, the CG, what is that CG? CG, that is your moment of area, and that is purely dependent on the free surface, or from where we are going to find the moment of area of any surface, that is maybe a square or rectangle, circle, or any uneven surfaces. So it is mainly calculated from the reference axis. So here it is your reference axis, that is the free surface, that is your free surface. So CG, that equals to area into perpendicular distance, where our perpendicular distance, that is H bar. So here it is the area into H bar, that is your CG, and the distance of H bar, that is the depth of CG, which is denoted by H bar, and the depth of center of pressure, that is denoted by H star. Again, what is center of pressure? As we already discussed, the center of pressure is nothing but the point of application of pressure. Where your total pressure is applied on the any surface, the point of application, this term or this point is known as center of pressure. Okay, so It was about the horizontal plane surface, and let's see the one example, simple example for this horizontal plane surface. In this case, we have one figure, figure number 3.17, where we need to find out the total pressure on the bottom of tank. On this bottom of tank, we need to find out total pressure. So this bottom of tank, that is act as a horizontal plane surface, because we are going to find out the total pressure on the bottom of tank, and the bottom of tank, that is, yes, obviously, which is horizontal, and that is again purely parallel to the free surface of liquid. So in this diagram you can see that here it is the free surface of liquid that is parallel to the bottom of surface. So first we need to find out total of pressure, second the weight of water in the tank, and third, that is the hydrostatic paradox between the 1 and 2. Here it is the old dimension, that means the length of this vertical column, that is zero point 0.4 meter, sorry, that is the width of vertical column, length which is 3 meter, length of this small rectangle, that is zero point 0.6, and the width of tank, that is 4. In this case, here it is in a 2-dimensional. If this tank, that is in 3-dimensional, like this, so we can have an idea that this tank is somewhat like this. Okay. So here that is the width of tank, that is 2 meter, which is given in our example, that is width of tank is 2 meter, like this. Okay. Here that is the width of, in a 3D, width of tank, that is 2 meter. Okay. So first of all we need to find out total pressure. Total pressure, that is again finding on this horizontal plane surface at the bottom of tank. Okay. So first of all we need to find out the total height of free surface up to this bottom of tank. So the depth of water on the bottom of tank, that is H1, that equals to this 3 meter height plus 0 0.6 meter, and that is total depth of height, that is 3.6 meter. Width of tank, that is 2 meter, and the length, this one is length of tank, which is 4 meter. Okay. So what is the area of bottom of tank? Area, that is length into perpendicular, or sorry, length into width, that is 4 into 2, that is your area. Okay, area of this tank, that is this 4 into 2, and that will be your 4 to the 8 meter square, that is the area of this tank. First thing we'll find out, that is the total pressure force, total pressure force F, that equals to, so the total pressure force on the bottom, that equals to F equals to rho g A h bar, and that is this equation, as we already discussed about this total pressure force, that is rho g A h bar, which is only applied for a horizontal plane surface which is submerged, fully submerged in a liquid. Okay. So simple applied this formula, which is F, that is rho g A h bar. Rho, that is the density of water, yes, G 9.81, area of this bottom of tank, that is 4 to the 8, which is already find out, and the AH bar, that is the CG, or the depth of CG from the free surface, depth of CG from this free surface, that is 3.3 plus 0.6, that is this H bar. This one is your H bar. H bar, what is the H bar? As we already discussed, in this case, CG, center of gravity of a plane surface, depth of CG from the free surface. Okay. So here that is 3.6, simply multiply this all the values and you can have an answer, that is 2825 in Newton, that is your pressure force or the total pressure at the bottom of surface. Next thing, we have to find the weight of water, and the weight, that equals to rho gv. Okay, weight W, that equals to rho into g into v, that is your weight. As simply we know that the weight is equal to nothing but mass into gravitational force. So this mass or density equals to mass upon volume. So the mass that equals to rho into V. From this equation, rho equals to mass upon V. From this equation, we can write that mass equals to rho into V. So this mass equals to rho into V. This mass is replaced by rho into V. Okay. So the weight that equals to rho GV. So this weight of water that equals to rho G and V. The V that is the volume of tank. Okay. Rho that is the density of water, G that is 9.81 and the volume of tank. Yes, volume of tank that is 3 into zero point 0.4 into the width that is the vertical column. Volume of this vertical column that is 3 into zero point 0.4 into 2 length, width into height plus for this bottom horizontal place there is the length which is 4, the height that is zero point 0.6 and the width that is 2, which is the total volume of this whole closed system. By the multiplication and a summation of these two values we can have the weight of water tank, weight of water in the tank that is 70632 Newton. Okay, so that is weight and this one is your force applied on this bottom surface, on this bottom surfaces. What is the hydrostatic paradox? Hydrostatic paradox it says that if you have a different types of container which is filled equally filled with the same fluid and that is connected from the bottom side, so the fluid in any shape of a container it will gain any shape of any container. That is your hydrostatic paradox. So from this result number 1 and result number 2, we can observe that the total weight of water in a tank is much less than the total pressure at the bottom of tank, and that will be known as the hydrostatic paradox. Here you can see that the total weight which is far less than the total pressure force, and that is your hydrostatic paradox. Okay, so thank you. This was all about our first surface, and that is our horizontal plane surface. So in a very next lecture we'll see about the vertical plane surface, inclined and curved surfaces. So for your task you need to write down all of these things, that is what is total pressure, center of pressure, definition of these two, also discuss the horizontal plane surface with its derivation and write down this example for the horizontal plane surface. Thank you.